This is a summary of differentiation rules, that is, rules for computing the derivative of a function in calculus. Elementary rules of differentiation: unless otherwise stated, all functions are functions of real numbers that return real values. Although more generally, the formulae below apply wherever they are well defined including complex numbers. Differentiation is linear. For any functions f and g and any real numbers a and b, the derivative of the function h, x, equals of x, plus bg, x, with respect to x's. In Leibniz's notation this is written as. Special cases include, the constant factor rule, the sum rule, the subtraction rule, the product rule. For the functions f and g, the derivative of the function h, x, equals f, x, g, x, with respect to x's. In Leibniz's notation this is written. The chain rule. The derivative of the function of a function h, x, equals f, g, x with respect to x's. In Leibniz's notation this is written as. However, by relaxing the interpretation of h as a function, this is often simply written. The inverse function rule. If the function f has an inverse function g, meaning that g, f, x equals x and f, g, y equals y, then. In Leibniz notation, this is written as. Power laws, polynomials, quotients, and reciprocals, the polynomial or elementary power rule. If, for any integer n then. Special cases include, constant rule, if f is the constant function f, x, equals c, for any number c, then for all x, phi euro squared, x, equals 0, if f, x, equals x, then phi euro squared, x, equals 1. This special case may be generalized to, the derivative of an affine function is constant, if f, x, equals x plus b, then phi euro squared, x, equals a. Combining this rule with the linearity of the derivative and the addition rule permits the computation of the derivative of any polynomial. The reciprocal rule. The derivative of h, x, equals 1 per Fahrenheit, x, for any function f is. In Leibniz's notation, this is written. The reciprocal rule can be derived from the chain rule and the power rule. The quotient rule. If f and g are functions, then, wherever g is non-zero. This can be derived from reciprocal rule and the product rule. Conversely, the reciprocal rule may be derived from the special case f, x, equals 1. Generalized power rule. The elementary power rule generalizes considerably. The most general power rule is the functional power rule, for any functions f and g. Wherever both sides are well defined. Special cases, if f, x, equals a, phi euro squared, x, equals arcs or 1 when a is any real number and x is positive. The reciprocal rule may be derived as the special case where g, x, equals a 1. Derivatives of exponential and logarithmic functions. Note that the equation above is true for all c, but the derivative for c less than 0 yields a complex number. The equation above is also true for all c but yields a complex number if c less than 0. Logarithmic derivatives. The logarithmic derivative is another way of stating the rule for differentiating the logarithm of a function, wherever f is positive. Derivatives of trigonometric functions. It is common to additionally define an inverse tangent function with two arguments. Its value lies in the range and reflects the quadrant of the point. For the first and fourth quadrant one has. Its partial derivatives are, derivatives of hyperbolic functions, derivatives of special functions, derivatives of integrals. Suppose that it is required to differentiate with respect to x the function. Where the functions and are both continuous and both and in some region of the plane, including, and the functions and are both continuous and both have continuous derivatives for. Then for. This formula is the general form of the Leibniz integral rule and can be derived using the fundamental theorem of calculus. Derivatives to nth order. Some rules exist for computing the nth derivative of functions, where n is a positive integer. These include, 4D Bruno's formula. If f and g are n times differentiable, then wherein the set consists of all non-negative integer solutions of the Diophantine equation. General Leibniz rule. If f and g are n times differentiable, then see also, vector calculus identities, differentiable function, differential of a function, list of mathematical functions, trigonometric functions, inverse trigonometric functions, hyperbolic functions, inverse hyperbolic functions, matrix calculus, differentiation under the integral sign, references. Sources and further reading. These rules are given in many books, both on elementary and advanced calculus, in pure and applied mathematics. Those in this article can be found in Mathematical Handbook of Formulas and Tables, S. Lipschutz, Emma Spiegel, J. Liu, Schuon's Outline Series, 2009, ISBN 978-0-07-154855-7. The Cambridge Handbook of Physics Formulas, G. Wone, Cambridge University Press, 2010, ISBN 978-0-521-57507-2. Mathematical Methods for Physics and Engineering, K. F. Riley, M. P. Hobson, S. J. Bentz, Cambridge University Press, 2010, ISBN 978-0-521-86153-3, NIST Handbook of Mathematical Functions, F. W. J. Ulver, D. W. Lozier, R. F. Beweiswert, C. W. Clark, Cambridge University Press, 2010, ISBN 978-0-521-19225-5. External links, Derivative Calculator with Formula Simplification, A Table of Derivatives.